This script is built entirely on documented, verifiable archaeology and physics. The peer-reviewed dioptron/rangefinder hypothesis published by physicist Amelia Carolina Sparavigna in 2012. The 2023 Norton Disney excavation, covered by NPR, the BBC, and The Conversation, and the published geographic and metallurgical data on the 130 known dodecahedra. In the last 2 years, a wave of YouTube videos has claimed that Grok AI independently solved the dodecahedron, sometimes with wildly contradictory results. Rangefinders in one video, forbidden necromancy in another. There is no credible, verifiable record of Grok or any AI system producing a peer-reviewed finding on this object. Rather than invent one, this script treats the real phenomenon honestly. Researchers and hobbyists have started running the dodecahedron's published measurements through AI pattern matching tools as an exploratory step. And what they're finding lines up with and stress tests a real hypothesis that already existed. That distinction is more interesting than the clickbait version, and it's the one this script tells. Hold a Roman dodecahedron in your hand and it does something strange. It gives you everything at once. 12 pentagonal faces. 12 circular holes, no two quite the same size. 20 small bronze knobs, one at every corner, so the object never quite sits flat. It always rests balanced on points. There's no lid, no hidden chamber, no inscription anywhere on the surface. You can turn it over in about 4 seconds and see the entire object. Nothing is hidden. And that's exactly what makes it the strangest problem in Roman archaeology. Most ancient mysteries come from absence. A burned scroll, a looted tomb, a shattered inscription. This one comes from abundance. Roughly 130 of these objects have been pulled out of the ground across northern Europe, and for close to 3 centuries, nobody could agree on what a single one of them was for. Lately, that old mystery has collided with a very new tool. Researchers studying the dodecahedron's geometry have started feeding its measurements into large language models, including XAI's Grok, to see whether a pattern that one physicist proposed by hand in 2012 actually holds up across the wider dataset. It's not a peer-reviewed discovery. It's closer to a fast, rough second opinion from a machine that's very good at finding structure in numbers. But it's pointing at the same answer a slower, harder, entirely human piece of research pointed at more than a decade ago. To understand why that matters, you have to start with the object itself. A Roman dodecahedron is small enough to close a fist around. Most examples stand somewhere between 4 and 11 centimeters tall and weigh between 35 and 580 grams. The largest known example tips past 1,000 grams. They're hollow, cast in bronze or a related copper alloy, using the lost wax method, a wax model built by hand, packed in clay, then melted out and replaced with molten metal. Lost wax casting destroys the mold every single time. There's no template, no shortcut, no do-over from the same setup. Every dodecahedron that survives represents a wax original built from scratch by someone who understood how to lay out 12 regular pentagons and close them into a solid without the geometry failing at the seams. Every specimen recovered with a secure archaeological context dates to the 2nd through 4th centuries AD. The High Imperial and Late Roman period. And the distribution is the first real clue. These objects turn up in Britain, in Gaul, along the Rhine and Danube frontiers, in the Alpine provinces, in Pannonia. They are essentially absent from Italy, Greece, Egypt, and Syria, the oldest, richest, most heavily excavated heartlands of the empire. Italy alone has been dug over for 4 centuries. If dodecahedra were common there, they'd have surfaced by now. Instead, this object sits almost exclusively in the band of territory Rome was actively conquering, garrisoning, and engineering, rather than the settled interior it had already digested. The first one on record came out of a field near Aston, Hertfordshire, in 1739, and was reported to the Society of Antiquaries of London. The verdict, more or less, was a shrug. Unmistakably Roman workmanship, purpose unknown. Every find since has repeated that shrug in slightly different words. Over nearly 3 centuries, a handful of explanations have kept resurfacing, and each one solves part of the puzzle, while breaking on another part. The varying hole sizes could take candles of different diameters, and bronze handles heat well. It's plausible on its face, and at least one specimen has a reported trace of wax residue, though that finding has never been broadly replicated. The problem is what a candle holder doesn't need. It doesn't need 12 mathematically regular pentagonal faces. It doesn't need a skilled bronze caster when a socketed lump of fired clay does the job for a fraction of the cost. And it doesn't need to be absent from Italy, where candles burned exactly as often as they did on the Rhine. This one went viral for good reason. Researcher Martin Hallett demonstrated on video that the graduated holes can be used to knit the fingers of a glove, one hole per finger width. It's a genuinely clever demonstration. But usability isn't evidence of use. A wine bottle makes a fine rolling pin. No dodecahedron has ever shown fiber residue, thread wear, or the grooves that repeated tension leaves in soft cast metal. And human fingers vary continuously in width. The holes on real specimens don't vary continuously. They step in fixed proportional jumps, which is the wrong shape of data for a glove sizing tool. This is the hardest theory to kill, largely because it's nearly impossible to falsify. Ritual explanations tend to absorb any inconvenient detail rather than being constrained by it. It's also the current working hypothesis of a Norton Disney history and archaeology group, the team behind Britain's best preserved find, based on the way their specimen was deliberately placed in a pit alongside other material. It's a serious, live position held by people who've spent years with the object. But it still has to explain why a supposed religious emblem is common on the militarized frontier and nearly invisible in the temple-dense, cult-rich provinces of Italy and the Greek East, geography that runs backward for a symbol of Roman religious life. This gets dismissed quickly, and for good reason. Nobody commits this much cast bronze and specialist craftsmanship to a token, and no Roman board game whose rules survive calls for anything like it. Every one of these theories closes one door and opens another. None of them accounts for the form, the holes, the cost, and the geography all at once. And that's the gap a very different kind of theory tries to fill. Rome's power ran on measurement. Roads cut famously straight across hostile terrain. Aqueducts carried water on gradients so shallow, sometimes a few centimeters of drop per kilometer, that they're hard to believe were achieved without modern surveying equipment. Legionary camps were laid out to repeatable geometric templates, from Britain to the Danube. None of that happens without people in the field who can measure distance and angle quickly and reliably, often in unfamiliar or actively hostile ground. Roman land surveyors, agrimensors, left behind a real body of technical writing, collected as the Corpus Agrimensorum Romanorum, along with descriptions of known tools. The groma, a cross-shaped sighting instrument with plumb lines, used to lay out right angles, and the chorobates, a long leveling bench described by Vitruvius, used to set gradients for aqueducts. Both are well attested, but surviving Roman technical writing is patchy, and there's no reason to assume the groma and chorobates were the only instruments a surveyor carried into the field. This is the foundation of the surveying hypothesis, that the dodecahedron was some kind of field instrument, a rangefinder or angle gauge used by the people building and defending the frontier. The clearest published version of this idea comes from Amelia Carolina Sparavigna, a physicist at the Politecnico di Torino, whose 2012 paper Roman Dodecahedron as Dioptron, analysis of freely available data, posted to the AR-14 Physics Archive, proposed the object as a dioptron, an optical sighting device used without lenses to measure angles and, from there, distance. The underlying principle is basic trigonometry that the Romans understood well. If you know the true size of a distant object, a surveying pole, a military standard of fixed height, and you know the angular size it appears to occupy from where you're standing, you can calculate the distance to it. Sight through the hole that exactly frames a known reference object. And that specific hole gives you a specific distance. Read off the instrument rather than calculated by hand in the field. Sparavigna's paper worked through the geometry of that equation using published measurements of surviving specimens, and it's been cited and built on by later researchers, including work exploring how the dodecahedron's hole ratios might correspond to distances in Roman feet. This reading is the only one that treats the varying hole sizes as functional rather than decorative. It explains the expense, because measuring equipment worth trusting is worth paying to have cast properly. And it fits the geography. A Roman legion on campaign wasn't only a fighting force, it was a mobile engineering corps, cutting roads, bridging rivers, and laying out a new fortified camp at the end of nearly every day's march. That kind of work needs measurement that's fast, repeatable, and, critically, produces the same number for two surveyors working the same problem 100 miles apart who will never meet to compare notes. The honest objection has never gone away, though. No surviving Roman text names such an instrument. No surviving relief or mosaic shows a surveyor holding one, even though Roman art does depict the groma. Sighting steadily through a hole held at arm's length is awkward without some kind of mount. And no dodecahedron has ever been found with a fitting for a pole or stand. The geography fits. The physics is plausible. Nothing about it is settled. This is the point where the story gets genuinely modern, and where it's worth being careful about what's actually being claimed. A dataset like this, roughly 100 objects, 12-hole diameters each, collected by different researchers with calipers over 2 centuries, is exactly the kind of thing large language models are being used to comb through today. Feed a model the raw diameters, strip away every archaeological label, and ask a blunt question. Is there a consistent mathematical relationship between the 12 holes on a single object? And does it recur across objects that share no workshop, no mold, and often no century in common? Because lost wax casting destroys the mold every time, no 2 dodecahedra could have been made from a shared physical template. Any recurring pattern would have to come from a shared method or standard carried in someone's training, not a shared tool. What people running this kind of analysis have reported is that within a single dodecahedron, the 12 holes aren't 12 unrelated sizes. They form a graded series, the smallest and largest bracket arrange, and the values in between are spaced by a roughly consistent ratio rather than a fixed arithmetic step. That distinction actually matters. A series built by adding the same amount each time is what you get from someone dividing up a space by eye or convenience. A series built by multiplying by a consistent ratio is what you get from someone constructing a scale meant to be read. It's worth being direct about the limits here. This is pattern matching, not proof. Large language models are extremely good at finding structure in numbers, including structure that isn't really there if you give the analysis enough freedom in how a ratio gets defined. That's a well-known failure mode, not a hypothetical one. No peer reviewed study has published a confirmed AI-generated proportional law for the dodecahedron corpus as of this recording. What can be said honestly is narrower and frankly more interesting than the headline version. Informal AI-assisted analysis of the published measurements keeps landing on the same kind of relationship Sparavigna proposed by hand in 2012, using ordinary statistics more than a decade before anyone thought to ask a chatbot. When a fast, rough machine method and a slow, careful published paper point at the same structure. That's a reason to take the underlying idea more seriously, not a reason to credit the machine with a discovery it didn't make first. Every version of this argument had the same built-in weakness. The pattern was being measured in old, corroded, sometimes overcleaned objects. Corrosion concentrates exactly at the edges of a hole. Specimens pulled from the ground in the 18th and 19th centuries were often filed, scrubbed, or reshaped by antiquarians with no concept of conservation. Stack those distortions up, and you get a real worry that any pattern in the hole ratios might be an artifact of 2 centuries of damage and inconsistent measurement rather than anything the Romans intended. Then, in June 2023, that worry got tested against a genuinely clean specimen. The Norton Disney History and Archaeology Group, a community team working with the commercial firm Allen Archaeology near Lincoln, England, was excavating a Roman period pit on the final day of that season's dig when a volunteer's trowel struck something that wasn't stone. What came up as reported by NPR, the BBC, and The Conversation was a dodecahedron in remarkable condition, the 33rd known from Britain, the first from the English Midlands, and one of the largest and best preserved examples ever recovered, at roughly 8 centimeters tall and 245 grams. XRF analysis by archaeometallurgist Jerry McDonnell found it was cast from a copper alloy of about 75% copper, 7% tin, and 18% lead. It had never been cleaned, filed, or reshaped by an antiquarian's hand. It had simply sat in a pit for around 1,700 years. That combination, near pristine condition, high-resolution documentation, and recovery by a team with no stake in any particular mathematical outcome, is exactly what any pattern claimed across the wider corpus needed to be tested against. It's a kind of specimen where if the proportional structure some researchers have described were purely an artifact of corrosion or sloppy historical measurement, it should have simply failed to show up. Instead, by the account of researchers who've examined it alongside the wider corpus, its measurements sit comfortably within the range described in the older material. None of that closes the case. The Norton Disney team's own current working theory, stated plainly on their website, leans toward a ritual or religious interpretation based on how their specimen was deliberately deposited. A reminder that the people who've spent the most hours with this exact object don't consider the surveying hypothesis settled either. The rangefinder reading remains plausible and unproven. The AI-assisted pattern finding remains suggestive and unpublished in formal peer review. What's changed is narrower, but real, a genuinely uncontaminated specimen, recovered under modern conditions, gave the mathematics a chance to fail, and it didn't. Zoom out, and the strangest part of the story was never really the object. It's the silence around it. Rome documented itself obsessively. Engineering manuals, surveying treatises, letters, graffiti scratched into plaster. Roman writers describe tools that have never been found in the ground. Here is a tool found more than 100 times over, cast at real expense, made to a standard precise enough that objects separated by hundreds of miles and decades of time still seem to share the same underlying mathematics, and not one surviving Roman sentence names it. The likeliest explanation isn't secrecy. It's that some kinds of practical knowledge simply live in trained hands rather than in manuscripts. A surveyor working a frontier problem in Britannia and one working the same kind of problem on the Danube frontier both knew how to use whatever this object was because someone taught them in the field, and neither one ever wrote it down because you don't write down the obvious. When the administrative machinery that trained and moved those specialists came apart in the Western Empire, that specific unglamorous, hands-on knowledge didn't fade slowly into the historical record. It simply stopped being passed on, and the objects it had produced were left behind for later centuries to turn over in their hands without the faintest idea what they were looking at. Whether the dodecahedron measured distance, calibrated some other instrument, marked ritual space, or did something nobody has proposed yet, the honest answer today is the same one archaeologists have been giving in different words since 1739, probably Roman, almost certainly deliberate, and still not fully explained. What's new is the toolkit being used to chip away at it. AR-14 papers doing careful trigonometry by hand in 2012, community volunteers pulling pristine specimens out of English fields in 2023, and most recently, AI systems scanning a century of measurements for a pattern a person might take months to spot. None of those tools has produced a final answer. Together, they've narrowed the honest range of guesses more than the previous 280 years managed on their own.